Welcome to Basic Mathematical Analysis class. Today we will discuss the application of supremum properties. Namely, we will discuss the properties. First property, let S be a non-empty subset of real number. Let S be a non-empty set of subset, right? Non-empty subset of real numbers are that is bounded above that is bounded above and let A be a number in R define the set A plus S equal to set of all A plus S such that S belongs to capital S. So this is our set. Now we will find out what is the supremum of this set. Okay. Then supremum of A plus S. This is nothing but A plus supremum of S. So this is the first property. That is, whenever you are having a set S and an element A belongs to R, first you find the set A plus S. Now A plus S is defined as A plus S equal to set of all A plus S such that S belongs to S. Now to find the supremum of this set, it is enough to find supremum of S and add to that supremum the number A. So let us see how we can prove this. Proof. First we assume that U equal to supremum of S. Then by supremum definition, X is less than or equal to U for all X belongs to S, right? Therefore, A plus X is less than or equal to A plus U, which implies A plus X less than or equal to A plus U for all X belongs to S, which implies A plus U is an upper bound of A plus U is an upper bound of A plus S. Am I right? Therefore, what you're having is supremum of A plus S is also less than or equal to A plus U. A plus U is an upper bound, so this value is less than or equal to this. That is, what you're getting is supremum of A plus S is less than or equal to A plus, what's U? U we have assumed as supremum of S. So A plus supremum of S. So we want to prove that these two are equal. Now you got one side of the equality, right? Sorry, one side of the inequality. So call this as equation A. Now we want to get the reverse one. Now if V is an upper bound of V is an upper bound of A plus S, then a plus x is less than or equal to v for all x belongs to S. Am I right? V is an upper bound of A plus S. So A plus X should be less than or equal to V for all X belongs to S. Therefore, from this we can conclude that therefore your X value is less than or equal to V minus A for all X belongs to S. So that what will happen? So that V minus A is an upper bound of S. Is an upper bound of S. V minus A is an upper bound of S. Therefore, U equal to supremum of S. Its value is less than or equal to V minus A. Since V minus A is an upper bound of S, U equal to supremum of S. That value is less than or equal to V minus A, which implies A plus U, take to this side, A plus U is less than or equal to V. Since V is an upper bound of A plus S, we can replace V by supremum. Okay. Since V is an upper bound, V is any upper bound, any upper bound of A plus S, we can replace V. We can replace V by supremum of A plus S. We can replace V by supremum of A plus S. Then we get, what we will get? A plus U from this less than or equal to supremum of V is supremum of A plus S. So I have replaced that with supremum of A plus S. That is, you can write it as A plus what was U? Supremum of S. Supremum of S less than or equal to supremum of A plus S. Right? Call this as equation B. Now from A and B what you will get? From A and B, what is A? C. Supremum of A plus S less than or equal to A plus supremum of S. Here is coming supremum of S plus A is less than or equal to supremum of A plus S. Now from from A and B, we get supremum of A plus S equal to A plus supremum of S. So supremum of A plus S equal to A plus supremum of S. This was the first property. We will move to the second property. The second one. Suppose A and B are non-empty subsets of R. Subsets of R that satisfy the property that satisfy the property A less than or equal to B for all A belongs to A and all B belongs to B, then supremum of A is less than or equal to infimum of B. Supremum of A less than or equal to infimum of B. Suppose A and B are non-empty subsets of R satisfying the property A less than or equal to B for all A belongs to A and all B belongs to B, then supremum of A is less than or equal to infimum of B. So we have to prove this. Suppose B belongs to B, we have given condition is A less than or equal to B, right? For all A belongs to capital A. For all A belongs to capital A. Which implies, what's the meaning of this? B is an upper bound, right? Which implies B is an upper bound of A. Which implies B is an upper bound of A. B is an upper bound of A. So that if B is an upper bound, means supremum of A should be less than or equal to B. So that supremum of A is less than or equal to B. What is equation 1? Now 1 holds for all B belongs to B. All B belongs to B. Then supremum of A is then supremum of A is a lower bound is a lower bound is a lower bound for B. Am I right? Supremum of A is a lower bound for B. Therefore, supremum of A is less than or equal to infimum of B. Right? Since supremum of A is a lower bound, its infimum is always greater than or equal to this lower bound. So supremum of A is less than or equal to infimum of B. That was your second property. Now coming to third property. Third one. Let capital A and B be non-empty bounded above subsets of R and let A plus B equal to set of all A plus B such that A belongs to A, comma B belongs to B. So A plus B is A plus B such that A belongs to A and B belongs to B. Then supremum of a plus b is equal to supremum of a plus supremum of b. Supremum of a plus supremum of b. Proof. So here what we want to prove? We want to prove that instead of finding supremum of a plus b, it is enough to find the sum of supremum of a and supremum of b. For a, b belongs to, for a plus b belongs to a plus b, we have a plus b less than or equal to supremum of a plus supremum of b. Therefore, a plus b is bounded above is bounded above by supremum of a plus supremum of b, right? Since a plus b is always less than or equal to supremum of a plus supremum of b, right? Therefore, a plus b is bounded above by supremum of a plus supremum of b. Therefore, what you're having is supremum of a plus b is less than or equal to supremum of a plus supremum of b. Since we have found that for a plus b, see a plus b is always less than or equal to supremum of a plus supremum of b for a plus b belongs to a plus b, right? Set a plus b. That means its supremum is also less than or equal to this value. So supremum of a plus b is less than or equal to supremum of a plus supremum of b. Call this as your equation A. Equation A. Now to get the reverse inequality, for the reverse inequality, fix any b belongs to b, then a plus b is less than or equal to supremum of a plus b. Okay, for the reverse inequality, fix any b belongs to b, then a plus b is less than or equal to supremum of a plus b. For all a belongs to capital A. So A is less than or equal to supremum of A plus B minus B. Am I right? For we are getting A plus B is less than or equal to supremum of A plus B for any B belongs to B. Now, if this is the case, then A is less than or equal to supremum of A plus B minus B for all A belongs to capital A, which implies supremum of a plus b minus b is an upper bound of a, is an upper bound of a. Am I right? For every a belongs to a is less than or equal to supremum of a plus b minus b. Therefore, this is an upper bound of a. So, what will happen if this is an upper bound means supremum of a should be less than or equal to supremum of A plus B minus B, right? So this implies, you can take B to this side. This implies B is less than or equal to supremum of A plus B minus supremum of A, right? For all B belongs to, this implies this is an upper bound, right? Consequently, what you're having, this is an upper bound, then supremum of B should be less than or equal to this. Supremum of B is less than or equal to supremum of A plus B minus supremum of A. Now we are finished, right? So from this you will get, that is supremum of A plus supremum of B is less than or equal to supremum of A plus B. So call this as equation B. So what was our first equation? Equation A, sorry, inequality A, that is supremum of A plus B less than or equal to supremum of A plus supremum of B. Now you got supremum of A plus supremum of B is less than or equal to supremum of A plus B. Now combining these two, you will get, now from A and B, now from A and B, we get supremum of A plus B is equal to supremum of A plus supremum of B. So we have proved the properties. Now my homework is check these properties for infimum and deduce the corresponding properties for the infimum. So our question is, can you replace the supremum with infimum in this case? If you are replacing, that means definitely there should be a certain change. Okay, so what was the change and what will resultant property of infimum? So with this, I'm winding up today's class here. Today we have discussed the three properties of supremum. First property was supremum of A plus some set S is equal to A plus supremum of S. Second one, if A less than or equal to B for every A belongs to A and B belongs to B, then supremum of set A is less than or equal to supremum of set B. And third property, supremum of A plus B is equal to supremum of A plus supremum of B. Hope you understood today's class. So thank you for your patient listening. Thank you.